Hey guys, so a few weeks ago, I made a video where I evaluated the integral of the square root of tangent x. And in this video, it's very simple. I'm just going to be proving that my really long answer from my last video is correct. So as you know, the integral of the square root of tan x, that the antiderivative, is 1 over 2 root 2 ln of tan x minus root 2 tan x plus 1 over root 2 tan inverse of root 2 tan x minus 1 over 2 root 2 ln of tan x plus root 2 tan x plus 1 over root 2 tan inverse of root 2 tan x plus 1 plus c. And today we're just going to be differentiating it, and we're going to show that this is in fact the right solution to my previous video. If you don't know what video I'm talking about, I'll just post the link to that video in the description so you can go have a look at it. All right, so ddx craziness is root tan x. So the derivative, so the constant, so this is equal to 1 over 2 root 2. It takes 10 steps, just to let you know. So this counts as step 1, this is step 2 right now. 1 over 2 root 2. Now we need to find the derivative of this part first. So the derivative of tan x is secant squared x. And I'm going to put the root 2 out front and then use the chain rule on root tan x. So times 1 over 2 tan x to the power of negative 1 over 2 and then multiply the derivative of tan x, which is secant squared x. Okay, over this stuff, tan x minus root 2 tan x plus 1. Okay, plus 1 over root 2, factor out the constant here, 1 over root 2. Okay, find the derivative of root 2 tan x minus 1. So times, let's factor out the root 2 here again, root 2 times, so again, 1 over 2 tan x to the power of negative 1 over 2. Times secant squared x. Over, so then over 1 plus this stuff squared. So 2 tan x, I'm going to write in brackets to show that what I'm about to write here is a perfect square. So 2 tan x minus 2 root 2 tan x plus 1. All right, minus, okay, so now we're here now. So 1 over 2 root 2 times, so we factor out the constant, find the derivative of this, so that secant squared x plus root 2 times, okay, now use the chain rule or power rule, 1 over 2 tan x to the power of negative 1 over 2 times secant squared x. over over this stuff. So tan x minus, no, sorry, tan x plus root 2 tan x plus 1 plus root 2 tan x plus 1 plus 1. And we need to evaluate this derivative. So factor out the 1 over root 2 plus 1 over root 2 times, so root 2, and then once again, apply the power rule to tan. I've never seen so many tans in my life. Are we in Brazil? Okay, root 2, tan x to the power of negative 1 over 2. I think I'm going to get sunburn after this video. Tan x to the negative 1 over 2 times secant squared x all over 1 plus this stuff squared. So 1 plus, shoot, brackets, there's a perfect square inside, 2 tan x plus 2 root 2 tan x plus 1. Wait, sorry. Is that right? No, I should have done this. Sorry, I apologize for not, yeah, okay. Plus 1. Okay, sorry about that. All right, so we're good. Step 2 is done. We're 1/5 of the way there. If I were to give this on a test and you made it to step 2 and did it correctly, I would give you like 8 out of 10 points. I would put this as a bonus question. You know what? For those of you in Calc 1 right now, I recommend you solve this with me. If you know how to do this problem and make it all the way to the end, then you will definitely get at least a 70% on your final exam. Okay, so you know what? I'll make it even better. I'm gonna label these steps because there's 10 steps in total. So the equals, that's part 2 of 10, and equal. So this is part 3 now. So that is equal to, okay, we're gonna break this down. 1 over 2 root 2. 1 over 2 root 2 times secant squared x minus, so root 2 over 2 is just 1 over root 2, but we have a secant squared x. So the numerator here is secant squared x. Secant squared x divided by root 2 tan x, like this. Okay, yeah, all over tan x minus root 2 tan x plus 1. Okay, plus, now here the root 2's cancel out with each other, and the same thing goes for here. The root 2 divided by root 2 is just 1, so that cancels out. So the factor of the constant is just 1 over 2, plus 1 over 2 times secant squared over root tan x in the numerator over the square root of tan x divided by, okay, so let's do some arithmetic. This is basically 2 tan x minus 2 root 2 tan x plus 2, because 1 plus 1 is 2. So 2 tan x minus 2 root 2 tan x plus 2. Now minus, okay, so 1 over 2 root 2. So 1, let's write that down first. 1 over 2 root 2 times, so let's see, that's secant squared x. Let's write down secant squared first. Plus root 2 divided by 2 is 1 over root 2. So the numerator here, what in this term would be secant squared x. Divided by root 2 tan x, basically. Divided by tan x plus root 2 tan x plus 1. All right, and now we have to evaluate here. Plus, so the numerator would just be secant squared over root tan x. Divided by, 2 tan x plus root 2 plus 2 root 2 tan x plus 2. Yeah. All right, so that is part 3 of 10. Okay, so basically, yeah, should I? You know what? I actually don't want to like jam everything into one space. So I'm just going to give you guys 5 to 10 seconds to look at this before I erase this. So pause the video if you want to process this. And now I'm going to move on to part 4. So everything goes to the trash can. Okay, so part 4. So moving on from part 3. That is equal to 1 over 2 root 2. One over 2 root 2, 1 plus tan squared x. Okay, so I thought that at this point, when I did it, I'm going to turn everything into tan first. So that will simplify things up a bit. So secant, it was originally secant squared x. I turned it into 1 plus tan squared x. Minus 1 over root 2. And it was originally secant squared x over root tan x. So 1 plus tan squared x over root tan x divided by, the denominator is still the same, tan x minus root 2 tan x plus 1. Okay, and then plus, so earlier it was 1 over 2, and then the denominator had 2 tan x minus 2 root 2 tan x plus 2. If you guys remember from that second term, you could actually factor out a 2 there, and that would be plus, so from this is going off step 3, so that's plus 1 over 4 actually, times 1 plus tan squared x divided by root tan x all over, so now after you factor out the 2, it's just tan x minus root 2 tan x plus 1. Okay, and the third term, minus 1 over 2 root 2 times, so secant squared x turns to 1 plus tan squared x plus 1 over root 2. So I factor out the root 2 from the next term, plus 1 over root 2 times 1 plus tan squared x over root tan x. All over, the denominator stays the same, so it's tan x plus root 2 tan x plus 1. And well, yeah, let's move down to the last spot. Actually, you know what? I think I can jam it in there. Plus 1 over 4. So yeah, because with similar logic here in the second term, the denominator, you can factor out a 2. So 1 over 4 times 1 plus tan squared x over root tan x all over tan x plus root 2 tan x plus 1. And for 4 steps, it seems like we've done like almost nothing, because this equation is still as lengthy as the first step, but this is where things start to get interesting, actually. First of all, notice in the first and second term, the denominator is the exact same value, tan x minus root 2 tan x plus 1, and tan x minus root 2 tan x plus 1, which means we can add terms together here. And the same thing for term 3 and term 4, the denominators have the exact same value, meaning we can combine these together. One more thing. Look here, 1 over 2 root 2 times negative 1 over root 2 is actually equal to negative 1 over 4. And this term are exactly the same. So they cancel out to be 0, this term and this entire term here. And this term right here, because negative 1 over 2 root 2 times 1 over root 2 is negative 1 over 4, plus 1 over 4 is 0. And they have the exact same term here with the same denominator. So let's just cross that out and cross this out too. And now we've considerably simplified the equation. So part 5. Technically, we're only halfway done, but we're actually more than halfway done at this point. So that's equal to 1 over 2 root 2. And it's only 1 plus times 1 plus tan squared x now. Over tan x minus root 2 tan x plus 1. And then minus 1 over 2 root 2. Times 1 plus tan squared over tan x plus root 2 tan x plus 1. All right, and now we need to combine these two terms together. So what I'm gonna do, I should have written it like tan x plus 1 and then plus, I'm gonna rationalize the denominator in both equations. So this, I'm gonna rewrite it like this. So this is exactly equal to, I'm going to rationalize the denominator on both sides to get rid of the square root. So it's equal to 1 over 2 root 2 1 plus tan squared over, and I'm going to rewrite it like this. So keep the non-square root terms on one part and the square roots term on the other part. So tan x plus 1. And I'm going to say minus root 2 root tan x. I'm going to separate out the constant this time. Yeah. All right. Minus 1 over 2 root 2 times, okay, so the numerator stays the same. Ooh, wait, what am I doing? Sorry. No, I need to rationalize the denominator. Sorry, I got ahead of myself there for a second. So we just say tan x plus 1 plus root 2 tan x. Remember, rationalizing the denominator right now. Over the same thing on the bottom. Tan x plus 1 plus root 2 tan x. And okay, so we do we're going to rationalize the second term too. So 1 over 2 root 2 times 1 plus tan squared x I'm writing slower, but that's because you guys can really take the time to embrace the magic of what's going on here. 1 plus tan squared x over tan x plus root 2 tan x plus 1. Whoa, wait, sorry. Sorry, I got ahead of myself there for a second. 10x plus 1. This is, group this together, plus root 2 root tan x. Okay, times, and now we rationalize this. So tan x plus 1 minus root 2 root tan x over the same thing down here. So tan x plus 1 minus root 2 root tan x. Okay, and that is equal to, this is part 7, is equal to, okay, so write out the constant term first. So 1 over 2 root 2. Okay, so let's do FOIL and distribute this out. 1 times tan x is tan x. 1 times tan x plus 1 is tan x plus 1, plus tan cubed x plus tan squared x. Okay, plus root 2 root tan x plus root 2. Yeah, so roots plus root 2. And then root tan x to the power of 5. I'm going to write it like this. To the power of 5. So tan x to the power of 5 over 2, in essence. And yeah, this basically it equals tan x plus 1 squared. It's basically a difference of squares in the denominator. Tan x plus 1 squared minus 2 tan x. So see, I told you the square roots cancel out in the denominator. It means we rationalized it correctly. Okay, now let's do the same thing on the second part. I hope this fits. I don't want to have to cram everything. 1 over 2 root 2 times, all right, so it's basically very similar to the previous term. Tan x plus 1 plus tan cubed x plus tan squared x. Except this time it's minus times minus root 2 root tan x. So 1 times minus root 2 root tan x is minus root 2 root tan x. And then these two terms to get multiplied together is minus root 2 root tan x to the power of 5. Or tan x to the power of 5 over 2. Over, and the denominator, it's basically the same thing here. It's tan x plus 1 squared minus 2 tan x. Okay, now we're 70% done, well, more than 70% done. So this all, okay, so these 8 terms cancel out. So because like we have the same value in the denominator and the same constant out in the front, except this one is a minus, these 4 terms cancel out together. First 4 terms here, and the first 4 terms here, because they are exact opposites of each other. One's completely positive and one's completely negative. So that, okay, and there's one more thing. Root 2, ignore these constants out here for a sec. Root 2 root tan x minus negative root 2 root tan x is 2 root 2 root tan x, and root 2 tan x to root tan x to the power of 5 minus negative root 2 root tan x to the power of 5 is 2 root 2 times root tan x to the power of 5. So number 8 is equal to 1 over 2 root 2. Let's write that down first. And times, so basically 2 root 2 root tan x plus 2 root 2 root tan x to the power of 5. Over, and the denominator, you guys can verify this for yourselves, but when you expand this squared out and subtract 2 tan x, the result is secant squared x. So it's over secant squared x. You can verify it for yourself, but I already did it, so I'm just going to write it like this. And that is equal to, okay, first of all, these 2 root 2s factor out here with this in the denominator. So cross these 2 root 2s out. And you can also factor out a root tan x in the numerator. So it looks something like this. So it's equal to root tan x. Let's factor that out. Plus, okay, you know what? Root tan x, and then 1, because, yeah, just times 1. And then plus tan squared x, because root tan x times tan squared x is tan x to the power of 5 over 2. Over secant squared x number 9. And as you know, 1 plus tan squared x is equal to secant squared x. So these two cancel out, and you're just left with a root tan x. So an equation so complicated is just equal to root tan x. Beauty is at its finest when it's simple. Wise words have never been spoken. That is the end of it all, guys. This was very satisfying to do. Thank you very much for watching. I love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.